Okay guys, so I would like to explain to you about stationary point. Stationary point, for example, we have this curve. Actually, stationary point, it consists with three kinds. The first one is maximum, minimum, or even inflection point. Okay, in order to understand or get comprehension on the concept of stationary points, okay, so let's see on this curve. For example, I have curve, an arbitrary curve. So if I have a gradient of a tangent line that passes a certain point, for example, I have this line. Okay, it's quite obvious if we have this. Let's say this is intercept perfectly. I have a interception at this certain point. Let's say this is point. Okay, we know the gradient, it's gonna be positive something. It's gonna be greater than 0, right? Because it's somehow it's inclining. What's it called? It's moving up. Okay, it's moving up. So gradient is gonna be greater than 0. And this one also, at this particular section, if we have any intersection point, tangent line that intercept any point here, okay, you know it's gonna be the gradient less than 0 because it's declining. Okay, moving down. How if I have a tangent line exactly intercept at this point, at the summit, at the maximum point? As you see, it's quite obvious that this line is a horizontal line. As it is horizontal, we know the gradient of horizontal line is equal to 0. And with our previous discussion, we know the gradient of a tangent line, we can obtain it from the first differentiation or first derivative. Therefore, in order to get stationary point, we just stick to this rule. Oh, I want to have the gradient dy over dx, and at this particular stationary point, my gradient would be equal to 0. So this is actually the basis of, or the basis of your formula why you use dy over dx equals to 0 for finding the stationary points. Okay, after this, later on we will also discuss about how to determine the nature of stationary points. Is it maximum, minimum, or inflection point? Okay, in order to get that, we will use second derivative, second differentiation. Okay, second differentiation is gonna be this one, d square y dx square, or the second derivative. Okay, we will discuss later on how we can get this one, but for now, let's stick to the formula. If it's less than 0, it is gonna be maximum point. If it's greater than 0, it's gonna be minimum point. Sir, how if I have it equals to 0? Is it possible? Yes, it is possible. If it's equals to 0, okay, it's not enough. Let me scroll it up. Okay, if it's equal to 0, it's gonna be inflection point. Okay, what is inflection point, sir? I will tell you later on when our discussion is about this. Okay, but for now, let's stick to this rule to determine our nature of stationary points. Just let's see, find the second derivative and you insert the particular point that is intercept. Then after that, we see is it less than or greater than 0 or even equals to 0. Then we can decide what point is that. Okay, I think it's quite clear. Thank you. See you again next time. Bye bye.